Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all students. So, as a replacement for the class this morning that I didn't manage to attend or to give my lecture, so I will give this video for your kind information and to discuss whatever related to the chapter 7 or week 7, which we will discuss on the selected applications of biomaterials and standard requirements. So let's take a look at the application of biomaterials. Selected applications, we have discussed based on different biomaterials, metallic, polymers, ceramics and composites, but this time we will discuss on the selected applications. I will say that among the advanced applications of biomaterial. I might be quick and fast for this topic, so I need you to recheck, reopen the slides that I gave to you in the ULearn, and then I need you to study by yourself, because some of the contents of this lecture notes are included in the mid-semester examination, which will contribute to 30% of the total assessments. So let's take a look on uses of biomaterials. So we have, for example, the replacement of diseased or damaged parts, okay, hip joint, kidney dialysis machine, aid to treatment, catheters and drains, assist in healing, sutures, bone plates and screws, aid to diagnosis, probes and catheters, correct cosmetic problem, augmentation, mammoplasty, chin augmentation, correct functional abnormality like cardiac pacemaker, and as well as improve the function of the heart, for example, for cardiac pacemaker and intraocular lens. And also we have some of the uses in, for example, viruses and infectious disease related contents. Okay, so and then this have been discussed as in the previous slides. Okay, examples of biomaterials applications. Let's take a look on the intraocular lenses. Okay, for example, by age 75, more than 50% of population suffers from cataracts, and they are made of the polymer-based PMM, silicon elastomer, and other materials. And in the United States, yearly 1.4 million implantations in that country. And good vision, this is for the eye. Good vision is generally restored almost immediately after lens is inserted. Heart valve, okay, mostly fabricated from carbons, metals, elastomers, fabrics, and natural valves. Quite variations of materials. It must not react with chemicals in body, as we know the term biocompatibility, attached by polyester mesh, and tissue growth facilitated by polar oxygen containing groups. So the detail will not be discussed in this class. And then as soon as the valve, this is the real actual picture of the heart valve, as soon as valve implanted, cardiac function is restored to near normal, not 100% normal, but near to normal. By leaflet tilting, this heart valve used most widely, and more than 45,000 replacement valves implanted every year in United States only, not all over the world. Banyak, sangat banyak. And then we have dental implants, sangat popular for dentistry applications, by using titanium fixtures, okay, placed in the bone of the upper or lower jaw, and allowed to bond with the bone. And most dental implants are pure titanium, okay, screw-shaped cylinders that act as roots for crowns and bridges, or as supports for dentures. And it is capable of bonding to bone, a phenomenon called or known as osseointegration. It is bioinert. There is no interaction or reaction in tissue, and no rejection or allergic reactions. So hold on. Okay, I'll continue. So as we move on to vascular grafts, okay, I'm not sure which part of the body needs this kind of device, made of PET, polyethylene terephthalate. Okay, of course, biostability is one of the most important thing. We have hip replacements, okay, pinggang, tulang pinggang. the most common medical practice using biomaterials. It must be corrosion resistant or high strength metal alloys. It normally made from high molecular weight polymers, and it is made of thermoset plastics. Okay, then we have therapeutic devices in orthopedics, sepakar tulang yang menggunakan this kind of devices, right? Application in dentistry again. Catheters in cardiology, ophthalmology, nephrology. Okay, dialysis machine, for example, is using biomaterials related devices. Drug delivery system, we will discuss in detail after this, okay, on how, for example, when you have headache, okay, you makan Panadol, how does the drug or the medicine go through to the whole of body and then go directly or cure the sickness in your head, for example. You makan masuk perut, tapi macam mana kepala you boleh improve ataupun diperbaiki masalah sakit tersebut. So we have drug delivery system. Future applications could be tissue replacement or tissue engineering. Okay, so let's take a look on the drug delivery. Drug delivery involves the design and development of intelligent cargo carrier systems that can deliver their cargo to specific parts in the human body on demand with control on the rate of delivery. For example, cargo will be the pharmaceutical or biological agent, which can be small molecules, DNA, RNA, protein, and peptide. Vehicle carrier could be the polymeric, lipid, and inorganic, and it is going to the specific parts in your body, the organs, tissues, and cells. Requirements for drug delivery based biomaterials must be degradable. Okay, byproduct does not have adverse reaction or toxic to host tissue. No metabolic reaction that will change or affect therapeutic or function of the drug. For each application, it will have their own control rate to suit the use of the drug. The challenges among them is the number one, control drug release, how it is released, well released or not. Targeted delivery, is it going to be delivered to the target place? The crossing tissue barriers and crossing cellular barriers. So, drug delivery vehicles, apa yang membawa drug tersebut kepada organ ataupun tisu yang diperlukan. For example, we have transdermal patches, macro size, yang tampal-tampal dekat badan. We have dendrimers, polymer drug conjugates with this size, nano size, nanoscale material. And then we have another nanomaterial, micelles, polymeric particles, liposomes, and polymeric capsules. If you look at these examples, only transdermal patches are macro size and others are nano scale or nanomaterials related biomaterials. Example of biomaterial for drug delivery, for example, we have liposomes as one of the drug delivery vehicle. Okay, a liposome is a pseudo-spherical vesicle composed of a lipid bilayer. Present advances in liposome nanotechnology drug carriers have resulted in better treatment of multi-drug resistant cancers and lower cardiotoxicity. Types of the liposomes that being employed as a biomaterial is as per written in this illustration. General method, we need to prepare the liposome. Okay, we have cholesterol, lecithin, and charge plus charge and dissolve in organic solvent. Drying down lipid from organic solvent in vacuum condition, dispersion of liquid in aqueous media, which is known as hydration, purification of resultant liposome, and analysis of the final product. So, what does it mean by drug loading in liposome? It can be attained either passively, so the drug is encapsulated during liposome formation, or actively after liposome formation. We need to have hydrophobic kind of drugs, not hydrophilic, like amphotericin B taxol or anamycin can be directly combined into liposomes during vesicle formation, and the amount of uptake and retention is governed by drug-lipid interactions. Trapping effectiveness of 100% is often achievable, but this is dependent on the solubility of the drug in the liposome membrane. Passive loading techniques include three different methods. Number one is mechanical dispersion, solvent dispersion, and followed by detergent removal method or removal of non-encapsulated material. So, example of biomaterial for drug delivery. Another example is hydrogel. Okay, hydro is based on water, and gels is non-solid or non-liquid. In the middle between solid and liquid, it is they are water swollen, can swell up to 95% with water. It is cross-linked with hydrophilic polymeric structures produced by the simple reaction of one or more monomers by association bonds, for example, hydrogen bond, or strong van der Waals interactions between chains. It can be prepared from natural polymers and synthetic polymers. Among the terminologies, you have been studying this, or you have learned this in engineering material subject during your first year of your study in UTEM. And then for drug delivery, it must be diffusion controlled, swelling controlled, and chemically controlled. So how it works? Okay, ini sangat penting. The mechanisms of hydrogels, how it works as a drug delivery device or drug delivery biomaterial. The chemical composition reacts to internal and external changes in pH, okay, whether it's going to be acidic or alkaline, magnetic or electrical field, change in temperature, and ultrasound irradiation, which trigger the swelling effect. And once it is triggered, the rate of entrapped drug release is determined solely by the cross-linking ratio of the polymer network. Okay, so again, it is a polymeric structures, okay, and based on hydrogen and van der Waals reactions between the chains of the polymers. And then we have the term smart hydrogel. It is temperature sensitive, pH sensitive, glucose sensitive, light sensitive, electric current sensitive, and sound sensitive hydrogel. So hydrogels as drug delivery systems and scaffolds for tissue engineering is the new norm of biomaterials. Okay, so based on this figure, we can see the mechanism of the function of both systems, and this is the table discussing the application of hydrogel in drug delivery. What polymer, what drug is carried within the system, as well as the application, what kind of disease, for example. Okay, we have nasal, pulmonary, subcutaneous, dan sebagainya. And then another table for types of nanocarriers for drug delivery. Okay, not focusing on hydrogels only. This one is hydrogel, and for this one in slide 32 is on all kind of nanomaterials or nanocarriers. Okay, basically this is for cancer treatment. Okay, nanocarriers and nanoparticles, including photovoltaic nanoparticles. We have these methods, arrangements, features, example of combinations, and advantage or disadvantage. And then we have another application, a selected application of biomaterials is for the blood coating surface. What is blood coating surface? Blood clotting factors are proteins in the blood that control bleeding. Process of blood coating start with vasoconstriction, activation of platelets, and lastly formation of blood clot. Features of blood biomaterial interactions are listed as below. Okay, absorption of plasma proteins, platelet adhesion, intrinsic coagulation, fibrinolytic activity, erythrocytes, and leukocytes complement activation. So this is blood biomaterial interaction. So this is the figure in the left hand side. When you have injury and then vessel contracts, what happens is platelet plug, and we have fibrin clot. So this is blood coating process. Avoid the injury or damage to be worsen. Okay, so dia tutup cepat-cepat dengan menggunakan konsep blood coating process. Biomaterial for blood coating process will be the polymer as the largest and the most promising. Kalau kita tengok, kebanyakannya adalah polymer base. Polymer base are among the most promising class for biomaterial. So the key success is that it is due to low cost, and this material could be synthesized with wide range of properties and functionality. Okay, characteristic of polymeric biomaterial kita dah belajar. Ni tolong fokus. Low density, high chemical stability, high surface finishing is possible, and low coefficient of friction. Then this among the example for biomaterial in the from the polymer base. Then we have another examples. And cardiovascular, commonly blood contacting application, is one of the main applications for blood coating surface. This is due to increase of probability of getting cardiovascular disease had increased in these coming years. The most popular application for applying polymeric biomaterial in cardiovascular, this is not only focusing on blood coating surface but other applications which can be heart valves, vascular grafts and bypass grafts. Okay, cardiovascular, example of the valves and the grafts. Then these are the advantages and disadvantages of polymeric biomaterial in blood coating surface. For example, it can produce high complexity item, tolerable physical and mechanical properties, biodegradable surface modification. But for the disadvantages, we have absorbed water and protein surface contamination, wear and breakdown. Wear is related to tribological properties of biomaterials and difficult to sterilize. This the fabrication method of cardiovascular implants. Okay, we have 3D printing, sangat glamour di saat ini. We have 3D printing method. We have selected laser sintering. You can have a look and read these statements for this fabrication technique. Another important application of biomaterial is on the bone repair and fixation. Okay, so we have function of human bone, of course, made up of the skeleton system. Principal functions to provide a frame. So badan kita ni ada frame to support the organ system and determine direction and range of body movements. And bone provides an anchoring point for skeletal muscles and ligaments. Okay, so functions of bones, okay, daripada atas ke bawah. Anatomic classification, what are long bones, what are flat bones. Okay, and then we have cortical, what is the metabolism, what is the structure, macam-macam Havesian canals, Volkmann canals. Alright, macroscopic structural classification, we have the macro structure of cortical bone. And then we have another macrostructure of cancellous bone. Right, woven bone, lamella bone, and type of bone fractures. Of course, we have banyak jenis dalam medical ataupun medicine. We have closed, open, transverse, spiral, comminuted, impacted, green stick, and oblique. So these are the description for the types of fracture. And then we have the concept of regeneration of bone. From its micro and macro structure is accomplished through a delicate balance between an osteogenic or bone forming and osteoclastic bone removing process by Brighton 1984. And then the process responds to changes in the static and dynamic stress applied to the bone. More stress, equilibrium tilts more towards osteogenic or bone forming activity, and in vice versa. This is known as Wolff's Law, 1986. So we have types of bone fixation. We have closed reduction or non-surgical treatments. For example, we have plaster of Paris, okay, yang cement tu, and splint. And then we have another kind of fixation, which is open reduction that needs surgical treatments, in which sometimes for external fracture fixation, they will use pins. For internal fracture fixation, they will use wires, screws, plates, or intramedullary nails. Ini kita akan bincangkan sekejap lagi in details. Tapi saya expect you baca lah untuk you faham. So what are pins? Okay, what are the functions? Hole fragments to guide big screws. Okay, and then high holding power can be achieved by high elastic deformation of surrounding bone, threaded screws, material of pins itself. Mestilah menggunakan 316L kind of stainless steel. And then it must be biodegradable pins made up of polylactic or polyglycolic acid that can be employed or for the treatment of minimally loaded fractures. We have types of pins, diamond or trocar, single or double, and then smooth and threaded. And then we have various diameter of K wire and statement pin dedicated for different parts fixation. The thicker the diameter, the greater the traction or the force or the straighten force. So this is example of pin. Holds the fracture parts in aligned and straighten it. Straighten the jari tu, the finger of the ni kaki tu. And then we have example of external fixation. Okay, this is the image. And then we have wires. Okay, based on Kirschner wires or are of medical grade quality for temporary fixation during the surgery or for temporary surgical implantation that only remains throughout the required time of healing, and they should be removed from the body by a secondary operation. Function to provide additional stability in long, oblique or spiral fractures of long bones. And then we have properties of K wire, high strain energy, high ductility, high durability, excellent biocompatibility, of course, as well as great corrosion resistance. Screws, type of bone screws, we have cortical and cancellous bone screws. Alright, we have self-tapping screws, non-self-tapping screws. Holding power, how it can be affected. Okay, and then the process, the principal application. For example, the fixation devices to lag or fasten bone fragments together, attach a metallic plate to bone. And then we have plates. You boleh baca in details the properties, how it is being used in the body, for example. Plates are used in buttress or retaining wall and applied force to bone perpendicular to the surface of the plate to prevent shearing or sliding at the fracture site. Buttress plates designed to fit specific anatomic locations and incorporate other methods of fixation besides cortical or cancellous screws. Okay, this details, another details of the plates. Example of plates, dynamic compression plate, type of bone screws, another example of bone screws. And then we have bone cement fixation. Normally is using polymethyl metaacrylate, which is PMMA, known as bone cement. Cement provides immediate stability or requires to wait for 12 weeks to bear full weight. PMMA as a grouting agent is a viscoelastic polymer and has ability to function as a shock absorber macam dalam kereta tu. It allows loads to transmitted uniformly between implant and bone, reducing high contact stress. Problems of bone cement interface arises from intrinsic and extrinsic factors. Okay, these are the intrinsic factors as well as extrinsic factors. Toxic effect, this devascularization. Many equipment need to avoid the minimize the risk of thick failure cement. Again, kita dah bincang tadi type of bone fixation, another kind of slides. Transverse fracture, spiral or oblique, green stick fracture ni kita dah belajar tadi. Crush, burst, avulsion, fracture dislocation of subluxation. And then we have internal fixation for the fractures. What are pins and wires? What it is for? Okay, another example. And then we have titanium pins. Okay, normally it will be made from pure titanium or titanium alloy, titanium, aluminum, and vanadium, following ASTM F136 standard as the most common titanium alloys used in orthopedics, bidang tulang pertulangan. Excellent biocompatibility, of course. Compressive, tensile, and bending strengths exceed the strength of compact bone, human skeleton by 3 to 5 times. High elasticity or elastic modulus, especially with fracture strength, and high wear resistance. And then we have stainless steel pins. Okay, kelemahan dia adalah low biocompatibility. And then we have hydroxyapatite coated pins, another modern biomaterial. Hydroxyapatite or HA coated titanium alloys. Survival rate higher than titanium alloys. Stimulate bone growth. More body will have more willing to accept. Okay, 316 LVM wire. Nitinol wire, which is pure titanium, ataupun biasanya nitinol ni is Ni, nickel, titanium, and NOL ni dia punya nama belakang lah, wire. So how it is made, the fabrication process, okay, what it is for, plates and screws, again, gambar rajah yang lain, okay. And then we have right ankle fracture with internal fixation. Plates, the function of plates, mechanical functions, as well as the process of making the bone plates, bone screws. Okay, ini kita dah bincangkan tadi, region of applications, manufacturing process for hydroxyapatite. Okay, number 1, grinding, and then forming by using injection molding and extrusion or pressing, drying or frying, and then we have finishing, polish hydroxyapatite. Alright guys, that will be the first part of this chapter or this week's lecture. Kita akan sambung selepas ini. I thank you so much. So this is the part 1 for this week's lecture. Okay. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.